I got one more lesson to talk you guys through, and then basically we have a day and a half to do some studying, okay? So I want to talk about the factor theorem. First thing I want to mention is terminology, and as much as you don't like it when I use different terms, you guys need to know what a root is and what an x-intercept is. They're the same thing. A root is an x-intercept. So like, for example, this function down here, there's one x-intercept. Here there's two x-intercepts. Here there's two x-intercepts. Okay. This is really important. A root is not a factor, but they're similar. Okay. What is the factors on this guy right here? Well, the factors are x plus 3, x plus 1. But what are the roots? Does that make sense? I think it's really important to have that terminology straight. If the factors are x plus 3 and x plus 1, the roots themselves are the opposite, the negative 3 and the negative 1. Does that make sense to everybody? Okay, that's really key because that's what the factor theorem is about. We're going to try to figure out how to factor something now. Okay. One more slide here. The factors themselves are the x minus something, x minus something, x minus something. The actual roots or zeros or x-intercepts would be whatever these numbers are. We're clear on the terminology? Okay, let's try an example. Here's our goal. We're going to try to find some of the roots of this function right here. Now, one of the ways you could do this, you have a graphing calculator. In theory, you could type them in your graphing calculator, couldn't you? Now, that being said, I'm going to also want you to have some algebraic skills as well. Okay, so we can try to find them algebraically. What if we were to use the concept we learned last day, okay, which was called the remainder theorem? Do you guys remember what the remainder theorem was? Okay. Let's say that we wanted to try to divide this guy by, like, say, x plus 1. Is it for sure going to divide evenly? How do we know? Okay, synthetic division works, but at the end of the synthetic division, how would we know if it actually did divide evenly? What are we looking at? The remainder. So if something does divide evenly, what would the remainder be? 0. Okay, well, rather than actually do synthetic division or long division, the fastest way was you plug in the remainder theorem, which is if x plus 1 is the factor I'm trying to test, what number do I try plugging in? Okay, let's try that. So I'm going to test f of negative 1. F of negative 1 means I'm hoping that x plus 1 is a factor.
Why are we doing this if we're trying to?
Okay, well, if it does divide evenly, it would be a factor. And if it's a factor, it can find us the root.
So are we just guessing with that?
Okay, and for your question, yes. So far, we're just going to guess. I just picked a random number to start with. So try plugging in negative 1. Let's see whether negative 1 is divisible. Negative 1 to the 3 minus 3 times negative 1 squared minus negative 1 plus 3. Laramie, you said yes to it being 0? Yeah. Anybody else double check? Yes? Okay, so if we're in agreement on this, make sure you listen to this statement real carefully because I'm going to even write it down. If the remainder equals 0, here's what this means. It's a long train of thought. If the remainder equals 0, then it means that it divides evenly. Does that make sense so far? So if the remainder equals 0, it does divide evenly, which means that x plus 1 is a factor, which means that negative 1 is the root. Does that train of thought make sense? But it all hinges on one thing. Does it actually equal 0? So for this first example, like kind of Amy asked there, how did I come up with negative 1? I just picked something, right? So if this thing is cubic, we've actually now found one of the roots. How many roots could it have? It could have up to 3 actually if it's cubic. 2 turning points, 3 roots. So let's pick another number that might work. Again, I'm just picking random numbers here. So if I just did x plus 1, why don't I try doing this for x minus 1? So that if x minus 1 is what we think could be a factor, what number do we plug in?
1.
Yeah, just positive 1.
So that number you plug in would be the opposite.
Exactly. So if the factor is x minus 1, the possible root is the opposite. Okay, but you have to have that terminology straight. Pretty much all I care about is, does this equal 0? If it equals anything other than 0, it doesn't divide evenly. 0? So then same logic applies. If the remainder is 0, it does divide evenly. If it does divide evenly, then it means it was a factor. And then if it was a factor, that means that that was the x-intercept. Does that make sense? So by this logic, then 1 is the root as well.
So 1 and negative 1 are both x-intercepts.
They're both x-intercepts. You know what? Now let's actually pull out that graphic calculator. Let's confirm it. So, give me a second here. So y equals, clear, x to the third minus 3x squared minus x plus 3. So as we look at this graph, visually are negative 1 and positive 1 the x-intercepts? Did you guys agree after you see it there? Hopefully that seems... There is a third x-intercept though, isn't there?
Yeah.
According to the graph, what does it appear to be at?
3.
I'm going to go with 3. Well, let's just test that then using this idea here then. Now, work backwards though. If 3 is the root, what do we think the factor is?
X minus 3.
Okay, so then we think x minus 3 is the factor, meaning that 3 is the root. Let's just confirm and see whether it does equal 0. Hopefully it does. Trying it out to 3. Because when we looked at the graph, it looked like the other one was 3. So I was just checking that one. So you got 0? So again then, 3 is the other root. Okay, let's try a wrong number. Because, I mean, so far we've been pretty lucky, right? Like, I've either given you numbers that work, or we kind of knew it going in. Let's just confirm this. Let's try a wrong number. Let's try, like, x minus 2. So, if x minus 2 is what we think the factor might be, we think 2 might be the root, but when you plug 2 in, someone says you get negative 3. Okay. If you get a remainder, does it divide evenly? Well, then it wasn't a factor. Does that make sense? Is that like train of logic flow? Okay. Here's what this means then. Let's say you needed to factor this thing. Here's what it factored to. X plus 1, x minus 1, and x minus 3. If we were to have FOILed that out, that's what the original equation probably was. Does that make sense? There's actually also a really easy way to confirm. Confirm using the constant term. What was the constant term of this original equation here?
3.
Positive 3? Okay. Take the 3 constant terms back here, like positive 1 times negative 1 times negative 3 times all your constant terms together. It should equal the constant term of the top one. Does that make sense? Yeah. So like positive 1 times negative 1 times negative 3 is positive 3. That was your constant term of the top one there. That's a good way of confirming. So what did I just show you? Well, I just showed you a way of how to factor. Right? There's only one problem. We're kind of guessing and checking, aren't we?
Yeah.
Right? Like, if I don't give you these numbers beforehand, you're kind of just randomly flailing away trying to guess at numbers. So first piece of advice I can give you is typically these numbers are going to be whole numbers. Right? Like it's not going to be x minus 4.97325. Well, that's not really nice of us to do. In theory, we could do that though, right? But for right now, we're basically stuck at guessing some whole numbers. We also typically go with lower numbers, like it's usually not x minus 372. That makes sense? Yeah, it's usually 1, 2, 3, 4, 5, something like that, right? Okay. So basically, here's what we just did there. The remainder theorem states that if you have a binomial of x minus a, what does PA mean? Well, it means plug in the opposite of that number, and it'll tell you the remainder. The factor theorem basically says if it's going to be a factor, the remainder better be 0. Does that make sense? Like this just puts into words what we just did. Okay. Do you guys remember how to do basic factor and otherwise? Like how to factor in general? So like if I gave you 3x squared plus 6x, could you factor that? It'd be 3x bracket x plus 2. What would the roots of that be then? This guy would give you a root of negative 2. What would this guy give you a root of? 0. That's not familiar? Like let's say this was equal to 0 then. Like x, how do you get x plus 2 to equal 0? You plug in negative 2. How do you get 3x to equal 0? 0. Do you guys remember how to factor this guy? Yeah, numbers that add to give the middle and times to give the outside. So if the factors are x plus 2, x plus 1, the roots, negative 2, negative 1. I'm going to say that a lot today because I think terminology is really important. You've got to keep straight what we're talking about. Let me skip down to the last one. Do you guys remember how to do difference of squares? Okay, good. That one's usually pretty straightforward. So if the roots are x plus 9, no, sorry, if the factors are x plus 9, x minus 9, the roots are plus 9 and minus 9. This last one here could come up though. Do you guys remember how to factor something like this? Okay, so we need numbers that add to give 7 and multiply to give 3 times 2, which is 6. 6 and 1 will do. Well, here's the problem. Quadratic equations give you roots. What if we needed factors, though? Does that make sense? Because what quadratic equations do is the quadratic just gives you what x equals. But what if we actually needed the factor? So that doesn't always work for us. So this is still worth knowing. Here's what we do then. We take the 3x squared and the 2, we write them over here. And then the 6 and the 1, we like split that middle term up into pieces. You guys remember this? You cut it in half. You do like 3x, x plus 2, 1, x plus 2. So then my question is, I don't care what the answer is for like roots so much. What are the factors? X plus 2 is one of them, and 3x plus 1 is the other one. You guys recall that? Okay. Okay, so just a reminder then, this sort of factoring, we still have to be able to do that stuff as well. Okay, so here's a good example of a question that was on your assignment then. Our goal now is to find some of the roots of this function here. And maybe the best way of finding these roots is to find factors. Like they go hand in hand, don't they?
How do we factor things though?
Okay, so how do we factor a cubic then? Well, how did we do the last example 2 slides ago? We found random numbers and we guessed and checked and tried to figure out whether any of them would work. Right?
Is that how we should always do it?
Okay, no. There's a rule that works. Okay, it has to do with what I pointed out back here. Where was it? These 3 numbers. Remember how like these constant terms, they times to give your constant term? We have an idea about how to figure that out. It's called the integral zero theorem. Okay. I have some words on it on here, but maybe I'll just try to put it in people's words instead. Okay. It has to do with your constant term. Whatever values your constant term is, the factors are multiples of that. Sorry, not multiples, factors of that. Okay, give you an example here. This guy right here is 6. I can tell you for sure that x minus 5 is not a factor. It would times to give way too much. Does that make sense? So it has to be 1, 2, 3, or 6. They have to be numbers that times to somehow give 6. Does Does that make sense? But it could be positive or negative though. Okay. So what we're going to do is we're going to test numbers like +1, +2, +3, and +6, and -1, -2, -3, and -6. How many of these numbers do we think should work? 3 of them probably should work, I'm guessing, right? So let's start testing. So you still do have a little bit of guess and check. So start with 1. 1 plus 2 would be 3. -5 minus 6. Is 1 going to work? Okay, let's do 2. 2 to the 3 would be 8. This would be another 8, so we'd be up to 16. Then we'd subtract 10 and subtract 6.
That works.
Okay, so if positive 2 works, what that meant is that f of 2 equaled 0. So 2 is the root. What is the factor? X minus 2. Okay, so this one did work, so I'll just circle it. Let's try another one. Try 3, I guess.
So you cancel the 6s.
For 3? Because 3 to the 3rd would be 27. Then 3 squared here would be 9, times 2 would be 18. 18 and 27? What was that? 45. And then if I subtract 15 and subtract 6,
24.
is it going to work?
No.
Okay. You know what? I have a feeling 6 isn't going to work either, because right off the bat, 6 to the 3rd is going to give me a really stupid big number, right? Then I'm going to add even more numbers, and then I'm only going to subtract away a little bit.
Or are we trying to get to 0?
0, right? Because it has to equal 0. So I'm guessing that 6 is out too. Why don't you guys try -1 then? I'll just not talk you through it. You guys test -1. -1 works. Okay, so for writing that, then what you would say is that f of -1 equals 0. Basically, when you plug in -1, the answer was 0, which means it does divide evenly.
So X plus 1 is
Good. And then we're hoping to find one more, probably, right? Now, here's an idea, by the way. Let's say you find 2 out of the 3 factors. Well, we need to make this guy a 6. Right? And we already know that -2 is part of it, and 1 is the other. So, like, -2 times 1 times what would give you -6? Plus 3. Plus 3. Does that make sense? Because if I wrote it out, -2 and plus 1 and plus 3, you see how -2 times the 1 times the 3 will give me the -6?
Even though we canceled it out.
No, because plus 3 means that the root
Oh, it's -3, yeah.
is -3. Does that make sense when I'm really harping on this terminology? Because you're going to get messed up with which one you're doing, right? Whether you flip it or not. You have to have that straight. So let's try that. F of -3. See whether that is equal to 0. It should be, I hope.
Do we have to factor cubes, or not cubic, but like working?
Yep. Have you seen the last question on your assignment yet?
No.
This is power of 6.
How far are we going to get to?
I mean, in theory, we could do this to anything, right?
That means we just have 6 more cubes.
I got 0.
Sometimes they're even multiples, right? Like you could have the same thing in there twice.
Is the way to do each of them the same though?
It's basically the same as what I'm just showing you here. You gotta look at your constant term, figure out which multiples could go in, and you just have to kind of guess and check a little bit.
That's it. Then we have to get to that.
Yeah.
This is my type of math.
Hey guys, actually, very easy.
No, sorry, this is like the best way.
This is my
Find the
type of math.
roots.
Yeah, to find the roots of.
these space.
Okay. Did that make sense then? Let's try another example. 'Cause I think just multiple examples work. It's, to be honest, guys, it's not as bad as you think. Okay? Take this one right here. Look at the constant term. What's the constant term? Okay, there's not a lot of ways to times numbers to get 3. That's basically it. So I've only got 4 numbers to test. The numbers I have to test are +1, +3, -1, and -3. So try those. See whether any of those actually work.
Why are those ones you choose?
Because that's the only way to get this 3 as that constant term. Does that make sense? Like when you multiply this guy by this guy by this guy, I can't have this be a 2 and a 5 and a 7, because then when you do 2 times 5 times 7, it's not going to be 3, right? So these numbers, they have to be combinations of like 1s and 3s. To be honest, can I even have 3 in there twice? Like if I have +3, could -3 also work? Because then when you times them together, it would give you 9, and that would be too big. So anybody find one that works yet?
Yeah, 3.
It should be
3 works?
-1 and -3 because what did your
So f of 3, you're saying worked? 2 times 3.
How do we know if we have to do
so that
this
means
one
that
twice?
it's 2 intercepts?
If you have to do -1 twice?
Because like,
Actually, there's another thing to it I've got to show you. Hang on one second on that question.
because positive one doesn't work, we can't have 2 3s.
Okay, hang on that thought, could you? Okay,
I told you.
No,
just want to make sure. Did everybody get that 3 worked? Was there another one that worked? -1 worked? Okay, so we also think that -1 also works. Here's what that means then. We believe that one of our factors is x minus 3, another factor is x plus 1. Here's our problem. I gotta try to find that remaining factor, but this number right here is gonna throw things off. There's a 2 sitting out front. Does that make sense? There's a 2 sitting out there. And so like, let's say this thing here was x minus 1. Because you see how like -3 times 1 times -1, that would give you the 3 we need in the in there. Is that going to actually give us, though, the 2 we need in front? Not necessarily. So here's the problem. This will find whole number roots, but sometimes factors look like this. And they have like a 2 sitting in front. And so it doesn't always work. Okay. Now in this case here, I think I can kind of guess and check and piece it together and say, well, hang on, let's test this now. -3 times +1 times -1 gives me a constant term of +3. And then like x times 2x, that should give me my 2x squared, right? Then I could FOIL it all out maybe just to make sure. Okay. There's another way though. Okay. So here's another option you have.
Wait, we can do that? We can just slap the 2?
Would that not make sense though? Is that not the only way that you'd get a 2 up front here? That makes sense? Here, let me try something else actually. This guy right here, does it make sense first that there has to be like, it can't just be x minus 1? Because how else are you going to get a 2 in front here? Does that concept make sense? Well, I know this guy's stuck in place and this guy's stuck in place. We've proven those ones already, right? The only way then to get this 3 back here is to make this half of the number here a -1. Okay? But this 2 right, this x right here, if you go x times x times x, how am I going to get a 2x to the cubed? So what if there's a 2 here? Well, if 2x minus 1 is my factor, what's my root?
Would it be like
If 2x minus 1 is my factor, what would the root for that be? 0.5. Okay, now was 0.5 ever on the list of things that we thought to check?
Why did we do?
Could we still check it?
Why did we do -1?
The -1 here, I knew this had to be a -1 because if this guy here is +3, and this is already a -3, and that's a +1, I'm already like up to 3, but like I've got 3 in the negative. So I knew that the only way to go this times this times this was to make this guy -1 so that we could get to 3. Does that logic make sense?
Yeah, but I don't know how we just randomly slap stuff in there.
So that one more time?
I just said I don't know how we can randomly slap stuff in there.
You can't put the 2 in front of like x minus 3.
I can't put the x in front of these guys right here because I've already proven that those are my factors. by proving that they're my
Why
roots.
don't we just like put it outside of the brackets in front?
Outside right here.
That's what would make sense.
Okay, because then what would happen is this 2 would also times by this 3, giving you -6. It would also times by this 1, and also times by this one here, right? And that would totally screw up your last term right here. Does that make sense? So I can't have that 2 sitting out front, otherwise it affects this number here. Okay, question for you guys then. If we think that the root is 0.5, I said this earlier, that wasn't on our list of things to check, was it? Okay, that's one of our issues, is that this is only going to help us find whole number roots to check. But could we still test 0.5 in the equation and see whether it works?
It works.
Try that. Like, take 2 times 0.5 and just confirm.
If you want to make X. You don't make X by itself. How did you get the plate?
This guy right here, I thought it was going to be 2x minus 1.
Yeah.
So then, like, if 2x minus 1 is my...
As a fraction.
Yeah, so like then like add 1, divide by 2.
It works.
That makes sense?
You just divide by 2, put it outside.
Wait,
Would
don't
it be a
think
negative?
that 2 outside the fraction?
No, don't put 2 out front. Sorry. Someone asked if we could put 2 out front.
Okay.
Okay, if you didn't hear that, the problem with putting 2 out front is that 2 would then FOIL into this 3 right off the bat, and that would give you -6. And right off the bat, I know that that's way too big for it to be the 3 anymore. Does that make sense? Right, so we don't want to try putting a number out front. Okay.
So wouldn't the root be -0.5?
No, because the factor was 2x minus 1, so the root would be the 0.5. Because like if this thing was negative, then the root is the positive of it.
But don't you have to do 0,
So it would be 2x minus 1 equals 0. You'd then add 1 to both sides, so it'd be positive.
Yeah, but then would that be subtracted? Or is it already?
It is now the root. The factor was 2x minus 1. The root is positive 1/2.
That's where you would on.
Okay, let me go back an example here. If this guy right here is the root, no, sorry, if this guy is the factor, the root is 3. Right? If this guy right here is the factor, the root is -1. If this guy right here is the factor, the root is 1/2.
Yeah, you have to equal 0, right? But wouldn't it be? Should it be -1/2?
What should be -1/2?
Yeah, I know you equals half, but don't you have to subtract?
Okay, but like,
That's where I'm confused.
okay, you know how like this guy is -3?
Yeah, that-
Often we just flip this guy to positive, right?
Yeah, that's
Same
what-
thing with this one here. Well, this guy was a negative. Shouldn't this guy here be positive then?
I guess, but that's.
Because
Oh my goodness.
in order to make 2x minus 1 equals 0, you have to add out 1 and divide it by 2.
No,
He gets that. I'm not sure why you're wanting to flip it back again though.
because I never.
Okay, we'll talk more
I
later.
get what you're saying.
Okay. Out of curiosity, were you guys able to follow that then?
Yes.
Okay, factoring cubics and quartics and higher up stuff, to be honest, part of it is really a bit of a guess and check, isn't it? You have to use a lot of like logical reasoning skills and figure out, well, if this is what I know for sure, and this is what I'm hoping to get, what fills in the gaps? Does that make sense? Like that is part of what you do. That being said, I do have another strategy you could try. So like, I don't know that I'd call this one a better way of doing things. So you guys? Oh. Oh, okay. If this is not, you know, like you don't really like guess and check, I do have another idea that could work. Okay. Let me just pick another example to work with here. We'll try this guy here. Okay. Right off the bat, I have a couple of things that I noticed. What's my leading coefficient right here? Okay, it means that I'm not expecting like a decimal answer root. Does that make sense? I don't think I'm going to get an answer of 0.5 or something like that. That being said, 24 sure has a lot of numbers that go into 24, isn't it? There's 1, 2, 3, 4, 6, 8, 12, and 24. And we got to do the positive and negatives for all of those. So here's another idea. Let's test and let's see that we can just find one of them that works. Just one. So like try the number 1. Does 1 work for all of this? 1 minus 5 plus 2 plus 20 minus 24. Does 1 work? We're probably going to have 4 when we're done, yeah. Did 1 work? No to 1?
No, no, no.
Okay, let's try 2. You may need a calculator to do that. Okay. So we're just trying numbers so we can see that we can find just one of the factors that could go into this. Because we think there's 4. Let's just try to find one of them. You found one?
No, I just, how do you know? How do you know?
It's easy.
Because it's the power of 4.
How do you find it so fast, Heather?
I don't know.
You're
I
taking
think
us
it's
all
really
off.
good.
I'm just kidding. You're making me
Which one did you find,
I
Heather?
got 0.
Yeah, 2 works.
Yeah.
2 works.
I got 80.
Oh.
2 works.
I got 2 works.
2 works?
Yeah.
Works.
Wait.
Okay.
Oh, but that's subtract, not add.
Okay, so if we're in agreement that 2 is a root, what would the factor for that be? Okay, so I'm just going to write that down. We think that f of 2 equals 0, which means we think x minus 2 is a factor. Now, if you wanted to, you could keep guessing and checking all these numbers for a while, but maybe you're not thrilled with that idea. Here's another idea. If it does divide evenly, we can do what we did yesterday, the long division or the synthetic division. Okay. Watch this. Just watch for a second here. Go minus 2, and we're going to divide it into 1x to the 4 minus 5x to the 3s, 2x squareds, 20x's, and minus 24. You guys recall the setup for yesterday? Because minus 2 is the factor. Right? And because what we're trying to do is we're trying to go x minus 2 divided into that stuff. That's why I'm really harping on this terminology. You have to know the difference between a root and a factor.
Okay.
You guys remember how to do synthetic division then? Pull down the 1, times these numbers, then subtract, times these numbers, subtract, times these numbers, subtract? Am I doing this right or did I screw up somewhere?
No, that's how I got it. So it equals 0.
You lost me.
So it's plus 3, or say it's 3.
But I'm going to get a remainder when I do this.
I got 0 when I did it.
Okay, what am I doing wrong here?
Yeah.
Pull down the 1. Negative 1 times 2 is negative 2. 5 minus negative 2 is negative 3, right?
Yeah.
2 times negative 2 times negative 3 would be 6. 2 minus 6 is negative 4. Negative 2 times negative 4 is positive 8. Subtract these guys. Oh, hang on. I'm going to get 12. Negative 2 times negative 12 is negative 24, which gets us 0. Because we're sub.
Or you're adding.
Oh, okay.
Okay. Okay. First question. Is it supposed to equal 0?
Yeah.
Okay, because it did divide evenly. Okay.
Wait,
So
those the numbers then?
those are the numbers. What is the 12?
Negative 12.
It's the positive 12, I think. It's the constant term. This is where your x will go. This is where your x squared will go. This is where your x to the 3 will go. So here's one way of writing this then. This thing is x minus 2 next to x to the 3rd minus 3x squared minus 4x plus 12.
Wait,
You can't go for
that.
Then you break down that thing.
Yes.
Oh, okay.
So then we do it again with this guy. But now the numbers I'm working with are a little different. Now, this x minus 2, we're just going to kind of leave them out there for a while.
Just keep it.
Yeah. We need to now find numbers that work with like the number 12.
1, 2, 3, 4.
Okay, so we've already ruled out 1 and 2, right?
It would work for you.
Well, I mean, if 1 didn't work for the first one, why would it work in the drop down one?
I don't know.
Okay, let's try 3 then. Try plugging 3 into this guy right here. Let's see what 3 goes into this guy. So do it for just this section right here.
So 3?
So yeah, does 3 go into this thing here? Does it give you a 0?
Yeah.
3 works? Okay, so I'm just going to leave that x minus 2 we already found off to the side. If 3 works, what is the factor?
X subtract 3.
Okay, so then what I'm going to try doing is synthetic division again. I'm going to go x subtract 3, and I'm going to divide it into this guy's 1, minus 3, minus 4, and 12.
Oh dear, what did you just do?
Okay. You guys said that 3 works.
Yeah.
It means that x minus 3 is a factor. I'm going to try dividing this thing here then by x minus 3. Let's try to break this guy down and break an x minus 3 out of it.
Oh, we're just doing the synthetic.
We're just doing synthetic again. So,
Good question. How'd you get x minus 3?
because apparently 3 worked.
No, then do you use it times 1 by like x minus 3 or just negative?
Just the negative 3. Yeah.
Is that the 0 to the middle?
Okay, we can work with that. So walk with this. 1 comes down, that becomes negative 3. When you subtract these, you get 0 in the middle, right?
Yeah.
That's okay, we can still do this. Negative 3 times 0 gives you 0. Minus 4 minus 0. You're really pulling down the negative 4.
Minus 12 is 0.
So it's
So it equals 0.
Okay, so first thing first, okay, just don't jump too far ahead. Did we get a remainder of 0?
Yes.
Okay, good. It means that x minus 2 was a factor. Also, x minus 3 is a factor. So I can now write this thing as x minus 2 is one of them, x minus 3 is the other one, and what's the remaining stuff that I still haven't factored?
X squared
X plus.
Well, this guy was a remainder, that guy's a constant term. There's no x's. That guy's x squared.
That's a
so
perfect.
it's just x squared subtract 4?
That's a thing.
That's a thing.
That's a thing.
Is that like the last one?
Difference of square.
That's a difference of squares.
So
X
then
plus
it's
2, X minus 3.
I see now. I see.
I don't.
I don't.
Okay. So we go back a step here.
What? Stop.
Okay.
Why would you do that? Why can't we just leave it in X squared minus 4?
Because doesn't x squared minus 4 factor? Didn't we do that on like...
We have to make it smaller.
Because that's the whole point. Our goal is to factor, right? Our goal is to find all of the different factors.
Negative 2 and positive.
Our goal is to factor. How many factors do we think there would be? We thought there would be 4 factors. I've now found all 4.
So for the x to the power of 6, we have to do this a whole bunch of times.
Yeah.
Fun! It's so fun, guys.
I'll wait for the but.
But there should be only 6 factors.
We're hoping that there should be 6 of them. Yeah. Okay, Laramie.
Wait. What if you have a coefficient of like 2 or...
Okay, so if you have a coefficient of 2, what could happen is when you end up doing long division, you might end up getting like a 3x squared plus 5x plus 6. You could end up with that. And then you got to do the factoring that we covered back here, where you have to do like a complex trinomial factor. And there'll be one that has like a 3x plus 1 sitting in there. Complex.
Go back to where we Where? Where's the x minus 3?
This guy right here?
No.
This one right here? We took this remaining stuff right here, and we tried some random numbers to see which ones would work. And apparently when we plugged in 3, it equaled 0. So then we knew to try x minus 3 would work. Okay? And the idea behind that being that then when I long divided it, I got, not this stuff here, but I got this thing, which then I could easily see that it factored. Okay, trick question time. How many factors does this thing have?
3.
Let me change my phrasing. How many unique factors does this thing have?
What's that mean?
Okay, was one of them the same?
Yeah.
Yeah, that means that you guys remember when we talked about graphs before? I got some pictures here. Let me skip ahead. It's possible that you could have one root. It's possible that you could have two roots. But you see how this guy touched right here? We call that like a double root. That's what we just had right here. Where was this guy? It was x minus 2. See how the x minus 2 is in there twice? It means that the number 2, guys, the number 2 is a root, but it just barely touches at 2. Does that make sense? When you have something in there more than once, that's where something like this occurs. Where right here, 2 is like just barely touching it. Okay?
Yeah, then you know for sure, like there's two of them and he does that?
Does that make sense?
Wait,
Yeah, like
so
if
it
it just
doesn't go
if
like
it barely
like
touches
this,
right
it
here,
doesn't
like
go
this
all the
could
way
be
under.
x minus 1, and this could be x minus 2, but there'd be actually like 2 x minus 2 roots sitting right there.
Why is that?
Because it only just barely touches and doesn't actually go through, like say this one where it actually goes below. This could be x minus 1, x minus 2, x minus 3.
The first one only has one root?
Yeah, this one could be x minus 1, and then the remaining stuff doesn't factor at all. You guys know how you can use the quadratic equation? The quadratic equation means that it doesn't factor whatsoever.
And Ethan Greer, please come to the office.
A negative discriminant.
Liam
That's
Scott
also a possibility.
And Ethan Greer to the office, please.
Are these all cubic?
These three were all cubic.
And then one root happens because
So like this could be x minus 1, and then let's do like say x squared plus 9x plus a million. Okay. This would be the remaining stuff right here. If this stuff here does not factor, like whatsoever, like it's just impossible to factor, like quadratic formula fails you, factoring fails you, then that's how this would occur. You'd get one root right here, and then this part right here because this thing here is impossible to factor. Does that make sense? This one right here, it did factor 3 times. It's just you got the same factor twice. And then this one right here, you got 3 different factors.
If we looked at the root and we saw that those like
Factors?
qualities, yeah.
Oh,
And
okay.
then you know that like that it doesn't go between the line or through the line all the way, and then it has 2 roots that are the same.
Yes. Yeah, that's how you can tell.
I get what you're saying. Makes sense what you're saying.